Cool. All right. Well, thanks everyone for having me here. I'd like to really say thank you to Space 8 Games for inviting me today. So I'm a solution architect at AWS. I've been with the company for about 1.5 years now. Before that, my background was very much almost more of an infrastructure style background. And so just to give you a little bit of my background, it's predominantly about 10 years ago, I did a PhD which used genetic algorithms and high-performance computing to sort of figure out how to plan different types of networks. One thing I'll kind of set from the start is I'm not a developer, but I will be talking to you about development concepts today. So I absolutely love things like Stack Overflow and copy-paste. Just forgive me for that one. But you know, before I got into things like AWS, I was very much on an infrastructure side. So I focused on things like trying to figure out how exactly network traffic profiles might go over time. So I worked with an IT optimization consulting firm for quite a number of years, and that was really great. But a lot of my time was spent going out to customers, plugging in boxes, waiting a few weeks, getting results, waiting another few weeks to actually write them up, and then kind of looking at that and going, well, I think you probably need a faster network by X% in 12 months. And back then, it was quite a frustrating time because people were having to think, what am I going to provision my IT infrastructure for the next 5 years, depending on the cycle they were in. And so it's really, really important that they got that right. Otherwise, they're making a multi-million-pound investment in something that might not be fit for purpose. And so it's really great to be able to be here now to talk about things like serverless, where actually none of that really matters. So my kind of focus for today is give you a bit of an overview of serverless and development behind it. And then if the demo gods are smiling happily on me, I'll hopefully build a very basic serverless API in front of you as well. And that'll be involving a number of AWS-based services like CodeStar. And what this will do is it will show you how easy it is to actually get started from nothing and have a website up and running either on AWS or actually up and running locally on your laptop as well, and being able to very rapidly iterate with that. I'll talk a little bit about things like serverless deployment frameworks. I'll talk about using AWS SAM, which some of you may have used already. And then talk a little bit about how you might test and debug using that as well. So kind of going back to my introduction a little bit, we had this concept of what time was like before, really. So today, we can start thinking a bit more about a serverless world where actually there's no servers to provision. You don't have to think about buying hardware. You don't have to put an order in and hope that it turns up in 3 months' time so you can hit your targets. You can just go to a console, say, right, I want a certain amount of capacity, fire it up. Or you can look at things like AWS Lambda, say, here's my code, just go run it, and we figure out the rest. And so that can be really, really helpful when you're doing things like experimenting, for example, where you want the ability just to try different things out. You don't want to have that commitment that says this must work first time, otherwise I'm a bit screwed, really. So you want the ability to fail, and that's kind of one of our mantras these days, is that ability to fail fast and iterate fast as well. And so that's where a lot of things like the serverless technologies come in, because today you can create some code, you can chuck it in AWS, you can run it, you can test it. If it works, great. If it doesn't work, go back and rebuild it. And what's more, by using some of these serverless technologies, it actually scales as well. So you don't have to start to worry about things like provisioning more capacity as your user base grows. It will scale with that demand. And as you know, some of the guys were saying a little bit earlier as well, you're only paying for what you use, and with serverless, that becomes even more apparent. You're not actually operating hardware that's just sitting there waiting for an action to take place. You're just paying for it as it's in use, and when it's stopped being used, you don't pay for it anymore. And by using these kind of systems as well, you have things like availability and fault tolerance built in. So when you're using something like AWS Lambda, it's not the same as using, say, an EC2 instance where you've picked the availability zone, you've picked a region to put it in. With the Lambda function, you're saying, okay, I want to host it in a particular region, but you're doing the rest of that. So you're not necessarily worrying about making sure you've got multiple instances running of it. And one of the key elements really when you're running these type of functions is one around making sure it's stateless as well. So you can think about different event-based architectures and move away from that kind of monolithic style architecture that you may have dealt with in the past. You can actually start just dealing with situations where something comes in. And a good kind of example of this would be, say you were an electricity company, you were asking your customers to take photos of their meter readings and upload them using an app. And in the sort of more traditional world, that might be a case of, well, they take the photo, it gets uploaded to a central store, which could be S3, and then it gets batch processed overnight, uses some OCR software, and you get a result the next day. But if for whatever reason they might have shaky hands, might be a blurry image, well, you're going to have to go back to that customer and say, well, could you go outside again and actually take that photo? And that's a bit of a pain in the arse, to be honest. And so by moving over to a more event-based architecture, you can give sort of real-time feedback based on user actions. And that can be anything from a change in data state, or it could be a user uploading a photo and have an event triggered straight away that says, okay, we know there's a photo that's been uploaded into AWS. We're going to start a Lambda function now which will perform some kind of action based on that. And you know what? If it doesn't work the way it should do, we'll give that user instant feedback so they know that maybe they need to take that photo again. And really the kind of AWS Lambda function is the very core of this whole serverless ethos. And by using that, you just use your code as you normally would. You upload a variety of different ones. And you can interact with any of the AWS services off the back of that. So you can, if you're using Python, for example, you can use the Boto framework and just call any of the AWS services as you normally would. So when we start talking about building an API in terms of serverless as well, what I'm going to go through here is actually just talking a little bit about some of the frameworks behind it, and then we'll go on to that demo part. So there's a number of frameworks available today. Some of these you might be familiar with. Just a few to kind of call out. They do a number of kind of core features. So they're able to decompose an application effectively. So instead of dealing with this large monolithic application, you can decompose it into lots and lots of functions, and then use some of these frameworks to actually kind of stitch it back together and provide things like API endpoints to then interact with those functions. So that can be really, really useful. You'll see a few like Serverless, for example, is a very common framework. We've got AWS Chalice, things like Claudia as well. So Claudia is a Node.js-based framework. And with that one, you kind of build it much like you normally would in a sort of Express format. And you just then mount your API endpoints. And you have effectively things like this API endpoint here, where you just, in this case, say /hello world. Chalice is an AWS developed one, and that's built around Python. And again, a kind of similar thing. So if you're very familiar with Flask, this should be very similar to you, really. And it kind of works with annotations, so you can annotate your methods to sort of describe the HTTP endpoints that the function should be mounted against. And in this case, for example, you've got a very simple sort of route over here. And again, you'll just return the hello world function there. And that would then, in this particular case, it would involve a Lambda function and also an API gateway endpoint. So I'll kind of skip this bit, but because I bet right at the back of the room, there's no way you can see this, even with binoculars. But what it's effectively doing is it's showing Chalice on a kind of larger scale in terms of a few elements like routing, for example, error handling, and HTTP method support as well. But we'll kind of jump past that a little bit because probably no one can see that. So let's talk about SAM. SAM is our serverless application model, and we've got a rather cute little mascot for that as well. So effectively, what we've done is we've taken a lot of learnings that we've used over the years from running CloudFormation scripts, and we've actually generated this model which really, really simplifies it. So effectively under the hood, all SAM is CloudFormation, and you can actually inject CloudFormation scripts into it natively, so you don't need to worry about translating anything. But the problem with CloudFormation sometimes, if you're deploying a serverless app, is it might be rather long. So you might be looking at a kind of screen that starts up here, ends up down there. And with SAM, instead, you can simplify this massively and be a lot more concise in terms of your definitions. And so effectively, you can describe the serverless app in a few lines of code. So in this particular one, this is a bit of a SAM template. And there's a few different elements here. So this particular one is in YAML, but could be in JSON as well. And so behind the scenes, what SAM is going to do is deploy for you a whole bunch of AWS resources, so things like API Gateway, for example, to connect it up to your Lambda functions. And so when you're looking at this particular slide, you'll see a number of common sort of elements here. So you've got a handler here, which is just calling your particular Lambda function. You've got an index dot, in this case it might be an index.js page that you're calling. And then you've got the actual Lambda function itself, just get HTML. You can inject things like permissions and policies. So here we've just applied a policy that gives it access to actually call a DynamoDB table. And then down the remainder of it, you're effectively building an API which will answer any request. And that just kind of brings it out a little bit more to show you some of the mappings. But you know, the main reason that we really like things like SAM is it can take something like a SAM template and make something relatively simple, which can actually make something rather complex as well. So it's really, really simplifying some of the CloudFormation that you may have produced in the past to actually start building some of your applications. And in terms of that as well, Chalice is something else that can also create a SAM template for you. So all you do is you type Chalice package and the directory you want it to output to. And then what it'll actually do is it will create a deployment zip file for you, which actually contains all the code you need. And then it'll also include a sam.json file, which is the template definition for AWS. So the next element of this is called SAM local. And this is pretty much taking everything I just said, but making it so you can develop locally on your own machine. And so, you know, you're not always in situations where you've got access to the internet, or you may actually not want to test against a live Lambda function because you will still incur costs for invoking that. So actually you can run this on your own laptop. And it will create kind of mock API endpoints on the laptop as well, which you can interact with. So you effectively have a local HTTP server running, you have local Lambda functions running, and you can rapidly test against that without having to upload your code anywhere. And so it also helps you to pull out quite a few of the kind of logs and error handling that you might be dealing with. So again, you can sort of pick out parts of it which you might need to sort of go back on, but without having to go into something like, say, CloudWatch, for example, and look through the logs there. You can just do this all locally on your own machine. And what I'm really hoping is I can demonstrate this to you very shortly. So fingers crossed this goes all right. And so this is the part where I sort of take a deep breath and move into the sort of console itself. And so what I'll do is I'll just kind of talk you through what I'm going to do here. And this is something that any of you can just try as well using an AWS account. So I'm just going to come out of the presentation quickly, and I will move back onto, cool. Yeah, so for those of you who aren't aware, this is the AWS console itself. As you can see, we have quite a few services there, and they cover a lot of different elements. The ones I'm really interested in today are actually CodeStar. And so what CodeStar is, it's a way of building a project very, very quickly in AWS that incorporates a number of different elements, and it can be everything from a CI/CD pipeline right through to actually being able to go and monitor it, deploy it, iterate quickly. Now, I have one in the bag just in case the demo doesn't work, but let's try and go and do a new project. So you get a number of different options here, and as you can see, it supports a variety of different languages. What I'm going to do is look at a web application, and in this particular case, I'm going to go for a Node.js one, and then you know what, we're going to do a Lambda function as well and make it nice and serverless. So this is my project template. I'll just give it a name, so in this case I'll call it Space Ape. And one new feature which actually just appeared in the last couple of days is the ability to actually use GitHub as a repository if you don't want to use AWS code commit. So you've now got another option in terms of where you actually store your code. I'm going to go with code commit. And so when I hit next, it gives you an option to review the project details, and I'm just going to hit that create project straight away here, and then I'll talk you through some of those elements. But effectively, the idea being you take it from that initial source, you build a pipeline, and that pipeline is using things like AWS code build as well, and you can then deploy it. In this case, I'm not too bothered about Eclipse or Visual Studio, I'll just use the command line tools. And so what I'm looking for now is in the bottom area here, it's just saying we're creating your repository. This normally takes about a minute or so. And so I'm going to try and kind of talk around this while it's building and hope it happens rather quickly. Whilst it's doing that, I'll just kind of skip back a little bit here. And I'll just show you a few different elements in terms of what it actually comprises. So going back to the services, we have code commit, which I mentioned before. This is your, effectively it's an AWS hosted Git repository. Yeah. And on top of that, we're almost there. On top of that as well, we've got things like code build, code deploy, and code pipeline. And these all kind of come together to help you take that code from the initial sort of source code area right through to deployment. So it should be almost done there, probably being rather impatient. It always seems a lot slower when you're standing in front of people trying to do it than it does when you're sitting at a desk. But we're certainly hoping it does it rather quickly. But the key element of this part is it gives you a kind of centralized dashboard to take in every part of the code. When you push and you update, then you can see the pipeline automatically be refreshed as well. You can see it automatically updated. You can track things like versioning. You can look at things like having team members as well, being able to access it. And so pretty much you should get all those different elements through. Okay, so because I'm being super impatient, I'm going to just go over to a code commit part as well. And you can see now it's actually creating that repository. And if I click through to that, it gives me this kind of view of it. It's a bunch of files here that have been created for that particular project. You've got things like a visualizer which will show you the commits over time as well, so you can track what's been going on with it. And you can branch it as you normally would as well. So I'm feeling rather confident now that I'll go back to this bit, and yeah, we've got our new code base now. So once that's once it's almost there, I'll get a URL, and that URL will be effectively a Git repo that I can just clone against. I'll give it there we go. So if I want to go and get it, I have this repo here. And so now I can just go and clone that locally and start playing with it. And in this particular case, I'm going to use Visual Studio Code. Just go and clone Git repository, paste in the URL there, and I'll just pick a new directory for that. And then it will just clone that repository for me. Just give it a few moments to do that. There we go. And we'll just open that one now. And so what you've got here is a series of files. I'll just show you the index.js file. And I realize that's super small, so let's see if we can just make that a little bit bigger for everyone. Yeah, just about. So it's a very basic file, this one, and the whole thinking behind it is just to actually show you a web page. What I will then show you is a tool called samlocal. So I will just go to the directory that's in, which is SpaceX Games. And again, I'll kind of really maximize this, so hopefully you can see it all right. Yeah, just about. So we go in there, we go to SpaceX. So what SAM does is it reads in this template.yaml file, and effectively all I need to do here to kick it off is type SAM local start API. And what this will do is it will create a mock API endpoint on my laptop. It's all based around Docker, so it's all run in a Docker container. And the code for SAM local is all up on GitHub. I'll show you the link for that. So this should be pretty much up and running now, and it's given me an endpoint I can connect to here. So if I'm feeling particularly lucky and I open a new browser tab, I should be able to connect to that now. And when you kick this off for the first time, it does seem to take a little bit pause, but there we go. So this is running locally on my laptop at the moment. I've got a local, effectively a local web server with an API endpoint that I can interact with. And you can do a few things with this in terms of actually modifying it, iterating through it quickly. So if I go back to Visual Studio Code, and I just do something pretty basic. I want to enable a bit of logging in there. So I just type in this case console.log, just type in hello. And so I'll just hit save for that. And then that's all I actually need to do. So now if I go back to my browser, I will hit refresh. And what you'll see is the same image here. But when you go back to the terminal window, you'll see that actually we get this new logging element here. So you can start actually iterating rather quickly based on this. And if you want to try and get ahead of yourself a little bit, you can always do things like commit the change as well. So put in here added logging, and I just save that and chuck that up there. And then hopefully what you'll see actually in the code star itself, if I go back to the dashboard, is you will see actually elements of where that's already been done. So go into the code commit part, go into the visualizer.
You need to push that. We just forgot to push that.
Yes. That always helps as well, doesn't it? See, this is why I bring Haytor along. He's the serverless expert. It's always handy to have him here. There we go. So that's been pushed up now. And so you can see it's already appeared in there in terms of adding logging. We've got a continuous deployment pipeline here, and that's also being kicked off. So we've got an element here showing where the commit actually was added just a few seconds ago, and the actual build pipeline itself is already been kicked off and being deployed as a new change there. So, that's just a really, really basic demo for you, but it's a way of trying to describe how quickly you can create something like a serverless demo, and you can actually work on it locally as well as in the cloud, so you don't have to be always connected in order to run these things. So I'm just going to jump back to the presentation itself, and so I think I was feeling relatively lucky there. I think that went fairly well. So effectively, what we've just deployed here, I can make my... it also helps if you pick the right one up. That's all. So, yeah. What we've just deployed there is effectively an API gateway endpoint, a Lambda function, and potentially we could have other AWS services in the background like DynamoDB to connect into as well. And that was just all built using a code star, SAM local to test it, and then pushing it back to AWS to actually run it in production. API Gateway has been mentioned a little bit tonight. For those of you who don't know, API Gateway is effectively one of the major connectors of being able to make people enable people to interact with Lambda functions through HTTP endpoints. So it provides effectively a RESTful API, and you can do all the usual API commands. It's actually fronted by CloudFront, and what that enables you to do is it allows you to deploy it across a large number of geographical areas, and it also has things like built-in DDoS protection as well. So you don't, going back to what I was saying at the start, you don't really need to worry too much about actually trying to think about these things yourself when you're starting out. It's certainly still important, and I would always recommend you do think about it. But you get a certain element of protection built in automatically that you don't even think about. And it provides things like authentication and authorization as well to allow you to have only authorized access to back-end functions. And you can even do things like throttle the API requests or monetize them. And I work with a number of customers today who do just that. So they have different tiers of API endpoints, and you might have a basic tier which accepts, I don't know, maybe 5 requests per second. You might have a premium tier that accepts 100 requests per second, or something in the middle, or something even higher. So it gives you quite a lot of flexibility there. Lambda itself, in case you're not fully familiar with it, it is very much a kind of bring your own code environment. It's already been discussed quite a lot today. You can bring your own libraries, like we were talking about with MXNet, for example, so you can upload either your native code. Effectively, on the back end, it's you've got Linux in there as well, so you can actually upload binary files. It's got a simple resourcing model where you just pick how much memory you allocate to it. And a really great tip for anyone using Lambda is think about how much performance you want, because the amount of memory you allocate to Lambda is directly proportional to the amount of compute and networking performance you get as well. So if you need a more powerful Lambda function, give it some more memory. And equally, if you need more network bandwidth, do the same. And actually, there are cases where it's cheaper to give a Lambda function more memory so it completes faster than to have an under-provisioned function which takes quite some time to complete. And then you can have a kind of flexible authorization model. You can work within either things like a VPC or provide it through public endpoints. And you can make it synchronous or asynchronous. So synchronous in the sense that you're interacting directly with an API call. Asynchronous as in you're interacting with, say, someone just uploaded an object to S3, and that upload of the object has triggered an event which is then called a Lambda function. And you know, in terms of authoring it through the browser, you've got effectively a WYSIWYG editor, so you can just natively code in the browser, or you can do it locally and then just upload it. You've got all the CloudWatch metrics to monitor it, and as I said before, the programming model effectively uses things like processes, threads. You get access to a temp directory. It's effectively Linux in the back end. But I think one of the key elements to think about with Lambda functions is they are stateless. So if you need to have this idea of some kind of persistent data storage, then using something like a Redis cache or DynamoDB, for example, to be able to put that data somewhere else, because there's no guarantee that that data will persist with Lambda. And it's got no affinity to any particular infrastructure. So you don't worry about that. You just worry about throwing up your function, really. And kind of as a quick summary, it's really never been easier to actually build these serverless functions. There's more and more elements now which are coming out to help you do that. And so the key takeaway is really not having to worry about things like managing servers, provisioning hardware, or even provisioning virtual servers, and trying to figure out how much disk space you need to allocate, how much CPU, and sort of provisioning that up front in the hope that you made the right decision. It's all will scale against what it is you're doing. And that scaling as well, that can be instantaneous. So when you're developing against Lambda, you might notice that it might be a little bit slower, and that's where you have this concept of kind of cold and warm starts. So what you see in development is definitely different to what you'll see in production when you're calling the same function again and again. And so that's something I would definitely urge you to kind of keep in mind if you're testing against it and thinking it's taking a bit long to respond here. So try testing again against it without changing the code, see if it's the same response time or if something's different there. And it's built in high availability and also things like authentication and authorization. So we've got quite a lot of resources on the website today. There's a whole sort of page dedicated to Serverless itself, and that covers pretty much everything I spoke about today. If you want to go deeper into the development side, there's also the developer tools element of this as well. And that can then start digging into things like, for example, some of the frameworks or the CI/CD elements. And finally, if you want to try this yourself, you can do exactly what I just did today. You can build effectively that website that I showed you. And if you do that, if you build an app in CodeStar, you can then if you click the tweet icon, which is on that website that you developed, and then you register using this particular link, you can get yourself $50 of AWS credits as well. So if you fancy an easy way to get some extra credits, I would certainly recommend you have a look at that. And that kind of covers the end of my talk. So thanks very much for listening.